Okay, so this is 8.5 part 2. Given the square ABCD and the translation vector V shown in figure 8.57, construct the translated square A prime, B prime, C prime, D prime. Okay guys, so the first thing we need to do is we need to draw the square onto the grid below, because I will not be able to translate it using vector V unless it is on the grid. So I'm just going to place it here. So this is going to be point A, and point B is 1, 2, 3 units over. So 1, 2, 3, here's point B. Because it's a square, we're going to have 3 units down and 3 units down here. So this is point C and point D. So we have A, B, C, and D. So let me go ahead and draw this in. So here is my square that's the exact same size as the one shown above. And we have vector V. Now when you use vectors, and I know I mentioned this in the last video, think about using a compass. We have north, south, west, and east. So when you do a vector, you always look at its direction. So this direction of this particular vector is southeast. You know, so if we picked it up and put it on here, we would see we'd be moving southeast. So either you're moving north or south first. So what I'm going to do here is I'm going to draw a triangle connecting the bits. Always start at the starting point, which is the dot, and you end at the arrow. So this vector is 6 units down. So I'm going to go down 6 units, and then it is to the east 3 units, or to the right 3 units. Okay? So what I'm going to do is I'm going to move each point down 6 units and over to the right 3 to use a vector to show the translation. So I'm going to use a different color. I'm going to use blue. And we're going to use that vector to translate it. So what I'm going to do is I'm going to go down 6 units and over to the right 3. So I start with point A. So I'm looking at point A right here. So what I'm going to do is go down 6 units. 1, 2, 3, 4, 5, 6. I'm right here. I'm just going to make a little X to show you where I'm at. That's down 6 units. And then I'm going to go over to the right 3. 1, 2, 3. And I'm going to put a new X here. So this is where I have the X is 6 units down and 3 over to the right. I'm going to go ahead and label that as point A prime. Okay? I'm going to do the same thing with B. So I'm going to start at the original point B and go 6 down. 1, 2, 3, 4, 5, 6. I have an X on it. And then 3 over. 1, 2, 3. So there's where I'm at. So once again, I took point B, moved it down 6 units over to the right 3. So this is B prime. Okay, I'm going to do the same thing with C and D. So I'm going to go to point C, the original point C, and go down 6. 1, 2, 3, 4, 5, 6, over to the right 3. 1, 2, 3. So this is C prime. Same with D. Down 6. 1, 2, 3, 4, 5, 6, over to the right 3. Okay? So once you have all your points translated using that vector, this is called a glide translation, I now have my new square. So this is my answer. So that's how you do it. So once again, use the vector, look at its direction. So when you read a compass, you read northeast or northwest or southeast or southwest. So make sure you're going up or down first and then over to the left or over to the right. Okay, so let's look at another example. Construct a glide reflection of the given figure. Okay, so here's the original figure. I'm going to just make it simple. We're going to make it a triangle. So this is triangle ABC. And we have a vector V here. So vector V is going to start here. And then we're going to go up 1, 2, 3, 4, 5. So vector V is going to end right here. So here's a vector V. So we are starting here and ending here. Okay, so if I have to use vector v, and by the way, vector v is denoted by a lowercase bold letter. That's how vectors are denoted. I have to move this figure. So once again, if you draw out, the directions, north, south, west, and east, we're going to see that this starts and goes in the northwest direction. So northwest direction. Okay, being that said, I can draw my triangle. So I'm going to use a different color like this. And we're going to go up first, and then we're going to go over to the left. So in this case, I went up 1, 2, 3, 4, 5 units. So I know I'm going to have to go up 5, and I'm going to have to go over to the west or over to the left 2 units. Okay, so vector v, I know I have to go up 5 and then over to the left 2. Okay, so I'm going to take all my points and do this. I'm going to start with A. I'm going to go up 5. 1, 2, 3, 4, 5. Put an X there. And then over to the left 2. 1, 2. Okay, so here's where my new figure is. I'm going to go ahead and erase that X. So this is now A prime. I'm going to move C. So I'm going to go up 5. 1, 2, 3, 4, 5. I have an X here. And over to the left 2. So here's C prime. And I'm going to go ahead and erase my X. B, go up 5, over to the left 2. So 1, 2, 3, 4, 5, over to the left 2. I'm going to put a little X. 1, 2, 3, 4, 5. And then to the left 2. This is my point B prime. Okay, so now all I have to do is connect the dots, or connect the points, I should say. That's the proper terminology. So we have triangle A prime, B prime, C prime. Okay, and that's my answer. So my answer is the translated figure. So once again, you can glide or reflect using vectors. Vectors give you magnitude, which is its length. That's why we have to go up 5 and over 2. And the direction, which is northwest. Okay, in this case. Symmetry. This is the last objective that we're going to be looking at. And symmetry of a geometric figure is a rigid motion, so we're not going to change a figure, that moves the figure back onto itself. That is, the beginning position and the ending position of the figure must be identical. So there's different lines of symmetry. So I'll ask you, hey, is this symmetrical about the x-axis, the y-axis, y equals x line, or y equals negative x line? So I'm going to show you an example of each one, and then we're going to go ahead and look at them and see if they're symmetrical. So the first example we're going to look at is the y-axis. So this is an example of symmetry about the y-axis. To check to see if a figure is symmetrical about the y-axis, you have to check to see if the points of each side of the line of reflection are equal distance and in the same position. So let's write this down to check for symmetry. So check for symmetry. To check for symmetry, are the points about the line of reflection equal distance from that axis? Are the points in the same position? And when I say same, I'm going to put that in quotes because, is it in the same position across the axis? Okay. If I fold the figure, there should not be any overlapping. Okay? All right. So going back to our example, the line of symmetry about the y-axis, we look at the figure, and if we look at it, we're going to see that all the points, like point B, for instance, is equal distance away from the y-axis as point H. Point A is on the axis, so we can't check that. Point C is equal distance from P as G is equal distance from P. Okay? Point F and D are equal distance away from the y-axis, and point E is on the axis. So if I fold that figure about the y-axis, would it have any overlap? And the answer is no. So is it symmetrical? Yes. So it is symmetrical about the y-axis. Okay, let's look at the x-axis. So the x-axis is here. Is it symmetrical about the x-axis? So once again, check your points. From point B to the x-axis and point D to the x-axis are equal distance away. Point A to P is the same distance as P to E. Point H to the x-axis is the same distance as F. So if I look at this, and if I pretend I folded across the x-axis, I would not have any overlap. So is it symmetrical? It is. So it is symmetrical about the x-axis. Let's check the line y equals x. The line y equals x is a diagonal line, which is a 45-degree movement away from the x-axis, which makes up the equation y equals x. So we're going to check for symmetry about this. So point A is the distance from point A to the line y equals x is the same as the distance from point C to the line y equals x. Point D to point P is the same as point H to point P. And point E is the same distance as point G to the line y equals x. So we can claim this is symmetrical because if I fold it over this axis, it would fold upon itself and I would not have any overlap. So it is symmetrical about the line y equals x. Okay, finally there's one more, and it is the opposite of the line y equals x. This is the line y equals negative x. And checking for symmetry, once again, check to see if the points are equal distance away. Point B to point P is the same distance as point F to point P. Point A to the line y equals negative x is the same distance as point G to the line y equals negative x. Point C to the line y equals negative x is the same distance as point E to the line y equals negative x. So we can conclude that this is symmetrical about the line y equals negative x. So those are your four possibilities when checking for axes of symmetry. Okay, so let's move on. Determine whether the polygon shown in figure 8.73 has reflective symmetry about each of the following lines, line L and line M. Notice that lines of symmetry are denoted as a cursive lowercase letter. So let's look at part A. So part A, line L, is this line here. So that's one we're checking out. So we're checking to see if each point is equal distance away. So if we look at this, point C is that distance away from line L, which is the same distance as point D to line L. Point E is the same distance as point B. Point A is the same distance as F to line L. And point H to line L is the same distance as point G to line L. So is this symmetrical? The answer is going to be yes. It is symmetrical about line L. Part B. So that's the answer for part A. Part B, we're looking at line M. So here's line M. And if we look quickly, we see that it is not symmetrical. Look at the distance between G and M. It's short. F and M is long. So is that the same distance around the line, about line M? The answer is no. So this is not symmetrical. And in fact, if I would fold this, we would see that we'd have a ton of overlap over the top of line M. So that's how you check for symmetry, and you do have some questions on homework and on the test that deal with this. And that is the end of 8.5.